Hello everyone, I'm Haofei Kwang. Today I want to introduce our new work, Video Contrastive Learning with Global Context. When we construct contrastive pairs for video-level contrastive learning, we always encounter two challenges, false positive pairs and local content. For example, for a dive video, if we just randomly sample two clips, sometimes they include totally different content, such as dive and award in the example. They are false positive pair. Besides, each clip only focuses on partial content of a long-range video, so it just includes the local content of the video. In this paper, we try to solve these two challenges. We propose a new sampling strategy to avoid the generate false positive pairs, then propose a contrastive learning algorithm to learn the global context from samples. This is our video-level contrastive learning framework. Shortly, we call it VClear. Firstly, for each input video, we will equally segment it into different parts. For example, we segment the video into 3 parts. Then we sample 2 frames from each part, construct 2 tuples. Here, we input each frame into an encoder to get the frame level embedding. For the global context, we treat the 2 tuples as a positive pair. By fusing the frame level embeddings of each tuple with the constant module, we can get the video level embeddings, then calculate the contrastive loss. The negative samples come from other videos. To avoid losing the internal relationship of videos, we add 2 more local contrastive learning tasks here, the interframe and intraframe contrastive learning. We select one of tuples firstly. For the interframe task, each frame of the tuple is treated as a positive sample. The negative sample comes from other videos. For the intraframe task, select one frame, throw 2 different data augmentation to generate a positive pair. Another 2 frames as negative samples. Besides, to force the model to concentrate on the temporal information of video, we add 1 more order prediction tasks as regulation. That is, we randomly shuffle these 2 tuples and ask the model to predict whether the tuple is shuffled. Okay, this is our VClear framework. To evaluate our method, we pre-train a backbone through our self-supervised algorithm, then use transfer learning on the downstream task for evaluation. We pre-train a 2D ResNet 15 on the kinetic 400 training set. The first downstream task is action classification. This is the result on 4 benchmarks. The results show our performance better than the state-of-the-art method and reduces the gap between supervisor pre-training. The second task is video retrieval. In this task, we generate the video level feature of the dataset and found the top k-matched feature between the training set and the validation set. We give the accuracy for the top k nearest neighbor. The results show that our model can extract a more general representation of videos, so our performance will be better than state-of-the-art method. The last is action localization on ActivityNet dataset. The action localization task asks the model to predict a proposal to cover a temporal region about the specific action as much as possible. Here, we fine-tune a BMN model. The results show that our method also works well on the task and has a little bit better than the state-of-the-art method. Besides, we also evaluate the performance of action classification on ActivityNet. The results show that our method works so well in the dataset. Here, we have some discussions about loss function, number of segments, and the 3D CNN. The results show that each loss works well on our framework, and the number of segments is crucial for the task. And our method also works well with 3D CNN. The last one is feature visualization. So in the visualization, it shows that our method will focus on the action in the video, but the other 2 methods will be influenced by the background. Okay, that's all. Thank you very much for your attention.